So I am on record now. If you would like to ask a question or something like that, or if I come out of share mode, I have to make sure I edit out your guys' likenesses. I think that's one of the stipulations about all this zooming stuff is privacy of you guys. So I am in record mode, and you can watch me. Who knows, if I post this on YouTube, maybe this geometry class will be going viral. You never know. I can hope. All right, so here's what we got. In the short term, you guys have 2 Delta Math assignments. I did videos on each. You don't need a graphing calculator for either one of them. So if you have questions, you could message me. You could ask me now, or you could ask me in class, hopefully when we're together on Thursday. The assignments are both due on Friday, as most of your asynchronous assignments are. So anyway, week of February 1st, what I did yesterday, I actually made little Zoom notes for yesterday's class, and I just copied them over, and I'm doing the same thing for you guys. And here's what I'm looking to do: is I'd like you guys to complete or develop a fact page about the planets in our solar system. Remember, we did something where I think we estimated how many Earths could fit into the sun by calculating the volume of the Earth and the volume of the sun. I think that's a nice connection to make. You know, we all know about the. I mean, I think looking into the sky and thinking about planets and stuff is really fascinating. I can just lose myself in that kind of science, really. I hope you guys have a similar connection to that. So I thought this is relevant to what we're doing in geometry, and here's how. Um, um, your fact page should include the planet's radius and circumference in both miles and kilometers, and also include the distance from the sun. And here's where I'm going with this. I want to do 2 things with your fact page. I'd like us to be able to develop a value for pi. And you guys know, hopefully, that it's 3.14159 something. I want you to see where that comes from. I mean, it's a number that you've been given. You've probably had it in middle school, if not sooner, and you've used it to calculate the area of a circle. Well, maybe you should. It's not a bad idea to know, if you're going to use a tool, where's that tool come from? So I'd like to develop a value for pi. And the second thing I'd like to do is I'd like us to work towards a scale model of the solar system. About a month ago, maybe 2 months ago, I was in Miss Englehart's room, and she has this most beautiful model of the solar system hanging from her room. And it's a bunch of beach balls, and it's very colorful, and it's just, you can just sort of get lost just staring up at the beach balls and the solar system. But the geometry teacher in me was thinking, it's not to scale. So I think it'd be illuminating if we were to try to do a scale model of our solar system and see what that would look like if we, well, if the weather's nice, maybe we'll go outside in the football field. And if the weather's not nice, maybe we'll try to make it down one of the hallways at Cedar Cliff. So anyway, that's the purpose of this this fact page. And I know it looks like, whoa, what are we doing in science class now? No, we're just collecting data from a science perspective that we're going to use in our math class. So if you would like to, if you have Excel, I'm going to open this file, Facts of the Solar System. And if you don't have Excel, it comes in the Microsoft Office package. I think as students and in the district, I think Google has something called Sheets, and you may use Sheets if you like. It's pretty basic as far as a spreadsheet goes. And here's where my question to you guys comes: is have you ever used a spreadsheet before? I do not know. And this is what one looks. I'm sure most of you have used a Word document. Spreadsheet. This is the first piece of software that I ever brought me to a computer back in the day. I mean, this was back in the 80s, I guess. I'm talking 40 years ago. It wasn't the word processor. It was a spreadsheet, and what it looks like is there's a bunch of these little boxes. Oops. See these little boxes? What's going on here? Box and box. It's a bunch of boxes. These are called cells, right? You put things in the cells, and There's so many of them. It's kind of like tiles on the floor, right? And it gets a little dizzying. And the way you orient yourself is notice that at the top, we've got A, B, C, D. These are the columns. And if I go over here to N, you can play around by widening the column, shrinking the column, that sort of stuff. And then along the side, we have rows, and they're numbered. The columns are represented in letters. And what happens when you get to the end of the alphabet? It comes after Z. Well, they do it with A's, and then they do it with B's. And it gets a little bit buggy as far as the syntax goes. But letters are usually represented along the top, and numbers are represented along the side. And any given cell, if I were to go right here, notice that I actually know my location. I am at the cell, let's see, E4. See that right there? E4. That corresponds to the E of the column and the 24 of the row. And if you get them to intersect, that's E24. Again, I apologize if this is something that you guys know, but I can't. I don't want to assume that. I don't want to assume anything, but that's the gist of the skeleton of a spreadsheet. Now, the things I want you to fill in is I just want the 8 planets of the solar system. What about Pluto? I don't know. Sometimes Pluto's a planet, sometimes it's not. And what I'd like you to do is to give me the radius in miles and the radius in kilometers. Radius is the distance from the center to the edge. And then circ, that's standing for circumference. I want the circumference in miles and the circumference in kilometers. And finally, the distance from the sun in miles and the distance from the sun in kilometers. And a very basic, I think I had a student that finished this during class yesterday. I want you to fill this out so that when we are together, we can develop the value for pi and we can start working towards our scale model of the solar system. So, and the scale model, I mean, this has to do with proportions. It has to do with the floor plan that we worked on. I think understanding this kind of stuff it's a very useful takeaway coming out of the course. So the when am I ever going to use this question? I think knowing how to model with scale is something that's important. All right. So all right, let's look for radius of the planets. And as soon as I start Googling, you're going to see, I've already Googled this, radius, equatorial radius of the planets. Okay, let's go there. And it sort of gives them right to you. This is kind of nice. Notice it provides these in kilometers, not miles. So I'm just going to start entering. Okay, I've got Jupiter here, which is 714. You can work along if you have a sheet. 71492. Saturn is 60268. Okay, notice I'm having the dimensions are expressed in the columns and the planets are expressed in the rows. Uranus is 25559. Neptune is 24764. And then let's see. I don't know why they didn't put these in order. Earth, or are they in order? Oh, I hate when they do that. They actually are in order, but because there's decimal values for Earth and Venus and Mercury, it looks like they're bigger numbers. Oh man, I hate when they do that. All right. They didn't ask me for my permission. They just went ahead and did it. So get a grip, man. All right. So Earth, its radius is 6378. The next biggest planet is Venus, which is, let's round that to 6052. And let's see, next to be Mars. which is 3396. And finally, Mercury is 2440. And there we go. And if you go to another website and your dimensions are off by a kilometer or 50, it doesn't matter. These are estimates, I'm sure. I'm a little surprised that they have tenths of a mile, of a kilometer for Venus. I honestly could not imagine that we're that accurate in measuring that. I guess we are. Now, what about miles? How are you going to get that? Well, one thing you could do is go to another website and look for the miles. You could maybe find them on this website. Maybe you specified different units. Maybe they reside on this website. What is it? Smartconversion.com. Okay. The other thing you can do is you could use the power of a spreadsheet, and I think that's worth the time to show you guys how that works. Here's the kilometer, and we want to turn this into miles. And we've got two conversions. 1 mile is 1.60934 kilometers, and 1 kilometer is 0.621371 miles. Okay, so pick your poison however you want to convert this. The way I'm going to go for this is, let's see, I'm going to sketch this up. Okay, so this expression right here, we've got 1 kilometer over 0.621371 miles. And that's an accurate, this is a conversion expressed as a ratio. We've also could say 0.621371 miles over 1 kilometer. These are the same value. They measure the same distance. Whatever the number on the top and the number at the bottom represent the same distance. The only is one is there's just a difference of units. So if we want to go from, let's say, Mercury's kilometers, and we want to go to miles. So we've got 2440 kilometers. Which one of these conversions are we going to use? Well, if we use this one, look what happens. We'll be multiplying kilometers per mile. And what comes out of that is we'll have kilometers squared per mile, which that is totally meaningless to most people. So let's go with the other conversion, see what happens. So we're not going to get this one. Let's try this for conversion. So this isn't science class. This is a math class. We're just doing sciencey things during math class. So we've got 0.621371 miles divided by 1 kilometer. Notice the kilometers cancel. So that's how we get from kilometers to miles, is we multiply by 0.62 and change. All right, let me in pen mode. I don't want to do that for all of these. Let's let the computer do this. So you go into the cell where you want the calculation to happen. Okay, I'm in Mercury right now. So what I want to do is now Google Sheets, I think I've used Google Sheets like twice in my life. I use Excel, and back in the day, I used to use something called Lotus 123. The way you would make a calculation from this cell here, we are residing in D5, is what we're going to do is I'm going to hit this is how I do it. You hit the plus symbol, and I'm starting an equation. Okay, I want a number. Now, what number do I want? Well, this is where you use your arrow keys and you start snooping around. What do I want to use? Well, I want to use that 2440. That's the number I want. And if I hit enter right now, I got 2440. It's kind of a funky way you could do a copy command. What's kind of interesting about it is, suppose I turn this into 3440. Since this is basically what this is doing is it's looking for whatever is in E5. It just copied it. So let me get back to what that should have been, 2440. Okay, and there we go. Now, I didn't convert yet. In order to convert, what I got to do is I got to multiply by 0.621371. So let me restart this. I'm going to look for a cell, or I want a calculation to happen. Then I'm going to go to the cell that's going to give me the number. And now instead of hitting enter, you hit times, and that's the shift 8. That's the time symbol. Our number is 0.621371. And that is the number of miles for Mercury's radius. Now we could do this 7 more times and get the miles for Venus and Earth and Mars and Jupiter and all that. We can do it a lot easier if we just copy this formula to those cells below. I'll tell you what, the one thing I want to do in advance is, remember how I was sort of griping a little bit about the decimals? Like when you look at this, notice we've got, am I okay on the clock? Which time have I got? 55. Okay, got about 8 minutes. I should be finishing up. I don't like the fact that the decimals are kind of cluttering up the numbers. These numbers are big enough. We don't need 5 digits of decimals. So let me format this cell so that there's no decimals. Here's how I do it. I go up into the format command, cells, and I want a number, and I don't want any decimals. I wouldn't mind having the comma separator for thousands, because when we get into distance from the sun, we get into the millions and billions of miles. I don't think it's a bad idea to have commas. So I'm going to put the comma in. And now, see, that's a lot nicer number now. 1516 is the miles. And now what I can do is, instead of running that calculation all the way through, I'll just copy it. So the way I do this in Excel, and sheets may be different. I'm going to copy, and then I'm going to paint where I want to copy to. That's called paste. And there you go. Those are the radius in miles and the radius in kilometers. All right. So while we're here, let's see if we can get the circumference of these planets. So as soon as I start to Google it, you're going to see, look, I've already done this. Circumference of the planets. I think I used this one. And again, depending on which website you go to, our numbers might not match exactly. That's okay. We're looking for circumference. So Mercury's circumference. Oh, and notice the last website we were at gave us kilometers and we had to convert to miles. This time it's miles and we have to convert to kilometers. So if I go to Mercury, that's 9522 miles. If I go to Venus, that's 23617. And Earth, that is, its circumference is 24889. I'm going to do one more because I'm aware that I'm on the clock here. The circumference of Mars is 13,256. You know what? Come on, let's just, maybe if I just pick up the pace. The circumference of Jupiter is 278,985. Saturn is 235,185. Now this is really boring if you're just watching me enter numbers. Hopefully you have your own version of Google Sheets or Excel and you're doing this alongside me. Uranus has a circumference of 99,739. And finally, we are finishing this. Neptune is 96,645. Okay, there we go. We entered all the circumferences. Now the last thing I got to do is, unless you want to go looking them up, you got to get the kilometers. Well, how do we do that? Which one of these conversions are we going to use? we've got miles. And if we multiply by, we want to multiply by kilometers per mile. And if we do that, then we're going to end up with kilometers. Okay. Well, so that means that I'm going to use this as my conversion. So if I have 9,522 miles on Mercury, I'm going to multiply by 1.60934 kilometers per mile. And notice the miles are going to cancel out. So that's the calculation that I'm going to do. And I've got 3 minutes to do it. All right. Okay. Now, what did I say I was going to do again? Oh, yeah. Okay. You go to the cell where you want the calculation to happen. This is the home. This is where I want the calculation. When it's done, this is where the number goes. So first thing, the way I do this in Excel, I'll hit the plus symbol, and that's what sends me on the journey to go look for a number. The number I want is to the left, so I'll arrow to the left. And now I want to multiply, that's Shift 8, by that conversion that we picked, 1.60934. And that is the circumference of Mercury. Let's format that up so that we don't have any decimals. Format, cells. I want a number with no decimals. And sure, let's put in the comma separator. There you go. And then just copy that. You're pasting it here. There you go. Again, I don't want you to be like sending this to Schoology to me. This is going to be a tool that I expect you to bring to class so that we can develop a model for the value of pi, or we can get a value for pi. And also what I'd like to do is work towards making a scale model of our solar system. All right. So I'm going to stop share. And there you go. Any questions, guys? All right, go out, work on your backflips. Be careful in the sun. If you're shoveling, lift with your legs, not with your back. All right.